Okay, on the back of this foldable thing, there are some steps. So if you turn the thing over to the back, you'll see step 1, step 2, step 3, step 4, and sometimes step 5. We're not going to do the sometimes step 5 ones today. We're doing step 1 through 4. And I want to just explain to you real quick what these are. And then we're going to go through them. We're going to go through them as we do some proofs. So up here on the top, write steps for proving triangles are congruent. That's what these are. So steps for proving triangles are congruent. Triangles are congruent. That's what's in this foldable. And let me explain to you where I got these steps. See, if you look up this lesson, and this was actually Friday's lesson and today's lesson. Fridays, they were just giving you the theorems, and today's they're actually going through proofs. If you look up that lesson in the book, you're not going to see these steps. So let me just real quick tell you where I got these steps. So yeah, I've told you all this before, right? That I've taught this course now. This will be year 27. This is 27 years in a row that I've taught this course, okay? So that's a long time. Well, the first, let's say about year 5 or so, I started wondering why some kids could do proofs and some kids couldn't do proofs. And it had nothing to do with intelligence, okay? So people say this all the time, well, he's just really smart, so, or she's just really smart. Well, everybody's smart, like in something, right? And I don't know if y'all know, but intelligence is changeable. Like you don't have a fixed intelligence that you're born with that's your intelligence the rest of your life. Did y'all know that? Like that you can change your intelligence? I think that is a misconception that you can't. So I did not buy into the notion that there were just smart kids and not smart kids. And the smart kids were going to be able to do proofs and the not smart kids were not good. I just would not buy into that notion. Otherwise, why would I be teaching y'all? That's crazy. So anyway, I started looking at their papers and trying to figure out why were these kids provers and these kids were not provers. Like, what was the big deal? What was the big difference is what I mean. So I started noticing that the kids who could do proofs every time consistently did these 4 steps. And so I wrote them down and I figured, okay, this could be a method then. If all the kids who could do proofs did these things, then there must be something to this. And that's what I'm sharing with y'all, okay? So I'm going to go through them real quick. It's going to seem a little vague until we actually apply it. So step 1, this is what kids who could do proofs always did. They marked the drawing, the figure. So proof problems are going to come with like a drawing or a figure. And the kids who could do proofs consistently would mark the drawing with what was given to them. So you are given some information and you're given a figure and they would mark it. And what I figured out they're doing is they were kind of pre-planning their proof before they wrote it down. It's kind of like jotting notes about a paper before you write it. You know, they were kind of pre-planning it. And then step 2. Step 2 is where we normally start proofs. That you would start your proof, your written actual body of your proof, by copying down the given. So step 1, they would mark the figure. Step 2, they would start the proof by copying down what was given. So step 2 is the given. And then step 3, this is where the thinking comes in, and this is where where the time will come in, where it takes time. They would find 3 congruences. And sometimes they would circle them. That wasn't really, they didn't all do that, but some kids would circle them to make sure they had 3. Now, I want to stop there for just a minute. Why do you think there has to be 3? Say that again? That's true, there's 3 angles. Not the reason, but that's true. So they would find 3 congruences. You're gonna need to do that too, find 3 congruences. Now think about the lesson though, y'all. Think about what this whole lesson's about. If you forgot what the lesson's about, turn the thing over. That's what it's about. Side, 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 angle, side, angle, 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 side. So why 3? Because there's 3 letters in each of those theorems, right? The first theorem has 3 sides. The second theorem has 2 sides and an angle between them. The third theorem has 2 angles in the side between them. Sorry, those are postulates. The first 3 were postulates. And the fourth one has two angles and a side knot between them. So all of the theorems require three parts. Not just any three parts, but a certain three. So that's why they would look for three congruences. And once they found them, three congruences, as long as it was one of those four theorems, side, 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 angle, or angle, angle, side, then you had congruent triangles, and so they could do step 4, state that the triangles are congruent by one of those things. Okay, so every single proof is gonna be done with those 4 steps. You're gonna mark the drawing, you're gonna start the proof with the given, you're gonna find 3 congruences, that's gonna take some time and a little bit of thought, and then once you've got 3, you can say the triangles are congruent. And every single proof, you go through that process, okay? So these proofs are not hard proofs. Some proofs in geometry are like hard. These are not, because there's a list of steps to follow. Okay, so now that's gonna seem a little vague until we actually do this. So open up to this right here. And for those of you who are watching this on film, I know this is off-centered a little bit, but at least we can all see. Okay, so we're gonna go through those steps. Step 1, you mark the drawing with what was given to you. I prefer to mark it in red, but you don't have to. I just prefer that. So we're gonna mark this figure with what's given. When you read this, the stuff that's given, make sure you read symbols so you know what you're talking about. This says segment AD. So mark segment AD with 1 hash mark. It's congruent to segment CD. Segment CD, 1 hash mark. So that's what it means to mark the given. You mark the figure with what's given to you. And then the next thing that was given was segment AB is congruent to segment BC. And so I marked that one with 2 hash marks. That's step 1. That's the first thing that successful provers did. They marked the drawing with what was given to them. Now, most of them were probably pre-planning this. They were probably thinking that these 2 triangles share a side, and that's all 3 sides, so I'm gonna prove this by side, side, side. So they're kind of pre-planning where it's going, but that was what the first thing they did. Question? And only 1 on the first time? That is an excellent question, okay? If I marked them all with just 1, that means that all 4 of them are the same length. And I don't know that. What I know is that these 2 are the same length, so I mark them with 1, and these 2 are the same length, so I mark them with 2, but I wouldn't mark them all with 1, because that means all 4 segments would be the same length, and they're not. So good question, and Alan, almost nobody asked me that. So it's such a good question. So the reason that's a good question, I assume people understand why I'm doing that, you know? And, you know, they don't, not always. All right, so good question, thank you. And so now I'm done with step 1. I have marked the drawing. Step 2 says start the actual proof. When you start a proof, we're gonna do it 2-column style, right? And so just like the proofs that we've done earlier this year, we're gonna have reasons in the first column, or sorry, statements in the first column and reasons in the second column. And we're gonna write down what was given to us. So I know that this is kind of tedious, but you're copying. Segment AD, congruent to segment CD, and segment AB, you're just word for word, letter for letter, symbol for symbol, copying what was given to you. AD congruent to CD, AB congruent to BC. That was given. Step 1, mark the drawing. Step 2, start your proof by copying the given and write given. Now, step 3 in doing a proof is find 3 congruences. Okay, look at our proof right now. How many congruences are there? 2. 1, 2. And we need 3. So this is where the thinking comes in, and this is where the work comes in. So marking the drawing, not a whole lot of thinking there. You're just putting marks to match what was given, and copying the given and writing given, not a whole lot of thought there. Finding three congruences, this is where it takes some time and some thought. Okay, so one thing I want you to notice is that in these congruences, what we're saying is a part of this triangle matches a part of this triangle. And we have two of those. So a part of this triangle matches a part of this triangle. A part of this triangle matches a part of this triangle. We need a third one. We have two. Okay, so let's talk about that third one. You will find yourself in a place on proof problems where you're looking for the third congruence, the search for the third congruence, right? It is almost always a shared side or vertical angles. Almost always a shared side or vertical angles. Okay, so look at these two triangles. Don't they share that side right there? Side DB. See, I'm looking for a part in the left triangle that matches a part in the right triangle. And they're joined in the middle at that side. So this side is the same in the left triangle as that side is in the right triangle. And so here's how you write that. You write side DB in the first triangle is congruent to side DB in the second triangle, because they share that line. And so I'm going to mark it. We talked about that on Friday, that if you have a line down the middle, you can put a mark there. And I use 3 because I already used 1 mark and 2 marks. Now, this you may not would know to put what I'm about to put for the reason without being told. I know it because Miss Thoreen told me to put this, okay? So you're likely going to know it because you were told, okay? So does this look familiar to y'all? Something equals itself. Anybody remember a property that says something equals itself? If you don't remember, that's okay. I'll tell you what it is. But anybody remember? Just curious. Okay, I'll tell you. It's called the reflexive property. You learned it in algebra, that a number equals itself, like 5 equals 5, or 3 equals 3. We didn't have a whole lot of reason to use it in algebra, but in geometry, this is where we use it. So it comes up right here. It's in the family with reflexive, symmetric, and transitive. So this one is called reflexive. So whenever you have a shared side, and this happens a lot in these kind of proofs, so you'll see this over and over again. If they share the line down the middle, you put that segment equals itself. What you really mean is that segment in the 2 different triangles equals itself. And it's the reflexive property of congruence. That's our third congruence. Step 1, mark the drawing. Step 2, copy the given. Step 3, find 3 congruences, and I just did that. And now I can say the triangles are congruent. See, once you have 3, that's 3 parts. And so the triangles are congruent. Now, it can't be just any 3 parts. It's got to be either all 3 sides, or 2 sides and the angle between them, or 2 angles in the side between them, or 2 angles in the side not between them. All right, which one do y'all think this is? What's marked? All sides, right? Sides, sides, and sides. So this, if you look at just this one triangle right here, all 3 of its sides are marked, side, side, side. So this is the side, side, side triangle congruence postulate. And you can just put SSS. So you're looking for 3 congruences, and those 3 congruences have to be one of those postulates. Okay, we're going to do another one, and then you guys are going to do the third one. Did I move that too soon? It'll tell me if I move this too soon. Everybody got it? Okay, second proof. We're going to go through the steps. And the steps, sorry guys, I'm just seeing if you can see it in that form. Okay, so the steps are, step 1, mark the drawing. Step 2, copy the given. Step 3, find 3 congruences. Step 4, say they're congruent. Okay, so it says point H. Point H is the midpoint. So you have to think back to chapter 1. Oops, y'all can't see that. There. Okay, point H is the midpoint of FJ. Here's FJ, this segment. So think back to chapter 1. If point H is in the middle of FJ, I'll handle IG in just a minute, but I'm just looking at one at a time. In the middle of FJ, that means that either the segments on either side of H have to be the same if H is in the middle. We learned that in chapter 1. So if H is in the middle of FJ, of this segment right here, that means that FJ must be cut in half if H is right in the middle. So here's how we marked that in chapter 1. We marked hash marks on either side of point H. That's how you mark a midpoint. So if H is in the middle of FJ, that means FJ is cut in half. And then it happens again to IG. Now, it doesn't always happen to both of them, but this particular problem says it does. So it's also, H is also the midpoint of IG. So IG is also cut in half. So this segment is cut in half, which means this half over here equals this half over here. Now again, I don't know that they're all 4 equal. I know that these equal each other because H is a midpoint, and I know that these equal each other because H is a midpoint. That's how you mark midpoints. And that's all they gave me. So now I go to my proof. So step 1, mark the drawing. Step 2, we're going to copy down this given stuff. So H is the midpoint, you can abbreviate midpoint if you want to, of FJ and IG. That was given. Okay, if you look at our given, there are no congruences in there. We don't have the congruent symbol at all. It just says H is the midpoint of FJ and IG. And I need 3 congruences, and right now I don't have any. But I have some in my picture because of what midpoint means. So here's kind of a rule of thumb. If you ever get stuck and don't know what to write in here, if you've marked your picture like you're supposed to do in step 1, you have congruences to write down. Whatever's marked here needs to be written here. Whatever's marked in here needs to be written in here. So I just need to write down those things that I marked. And I marked that FH is the same as HJ because of the midpoint. So segment FH is congruent to segment HJ. Now, if you remember way back in chapter 2, I think is where the first time we did proofs, I don't know if y'all remember me telling you this, but whenever there's a math word in the given, you almost always use its definition in the next step. And midpoint is a math word, and that's how I got that FH was the same as HJ, because of that word midpoint. So that's what the reason is. The reason is because it's a midpoint or definition of midpoint. I could have done that one first. I'm about to add it in here because it happens twice, right? So the midpoint.
You have to list both of them.
Right, and I would do them in the same step because it's the same reason.
Right.
Yeah.
Is there the same order?
No, the order doesn't matter at all. And in fact, the 3 congruences, the order doesn't matter as long as you've got the 3. Now there are some books that teach that if you're using side, angle, side, in the body of the proof, it's got to be sides and then angles and then sides. I just think that's being over picky. It's nice to be organized, but I don't think it's a requirement. So anyway, yeah, in that same step, we're also going to do the other one, that GH. So remember, whatever's marked has to be written, HI. And I don't need an extra step because it's the same reason. Now, if this problem had only said that H is the midpoint of FJ, and it didn't say that, then I would only have that first row. FH and HJ. But it said it was the midpoint of both of them. That's why I have 2. All right, how many congruences do I have now? I have 2 of them, right? And I need a third congruence. So let me go back to what I said a few minutes ago. You will find yourself in this place in every proof where you're looking for the third congruence. I mean, except for on the rare occasions where they give you all 3 of them, which is pretty rare. So you'll find yourself in this place where you're looking for the third congruence. It is almost always, the third congruence is almost always a shared side or vertical angles. So in this particular picture, they don't share a side, right? But they do have vertical angles, which we learned about in chapter 1. So vertical angles is our next congruence, our third congruence. This will happen on bow tie problems and hourglass problems. So like this one and this one, the one underneath it, when they cross at an X like that, you're gonna have these vertical angles. So that's our third congruence. So on almost every proof in this lesson, you're gonna have a shared side and put reflexive property, or you're gonna have vertical angles, and like in this case. So I've got this angle congruent to this angle because they're vertical angles. Now, you are not allowed to call them angle H. You're not allowed to say angle H and angle H because they're 2 different angles. So what I like to do is put a little 1 in there and put a little 2 in there and call them angle 1 and angle 2. Now, in your book, they don't do that. They name them with 3 letters. So they'll call this angle FHG, and they'll call this one angle IHJ. But I like to just put little numbers in there. So in your homework, you can copy the drawing, which I would do for every one of these problems anyway. I would copy the drawing, and you can name them 1 and 2 on your paper. Question?
Nobody just said that you would name it like angle FHJ or FHG and then IHJ.
Yep.
Wouldn't it be the other way? It would be like angle JHI because line J and F both have 1 line.
Yeah, when you name angles, okay, when you name the triangles, they have to match. The letters have to be in a certain order. When you name angles, they don't. But if you want to be consistent, you could do that and just keep them matched up no matter what you're naming.
Okay.
Yeah, so that's a good idea. Just so that when you're traveling down 1 mark and then 2 marks, you're traveling down 1 mark and then 2 marks. That's not a bad idea. With angles, you don't have to, but I would. Why not? So that's a good idea. What I really like to do, because I'm just so lazy, is I put a 1 and a 2 in there, so I don't even have to think about the order. But good point. So angle 1 is congruent to angle 2, and that is because vertical angles are congruent. You can either put the vertical angles theorem, or you can put vertical angles are congruent, because that's what the vertical angles theorem says. So I don't care which one you put, whatever your preference is, vertical angles theorem or vertical angles are congruent. And that's our third congruence, 1, 2, 3. And now we can say the triangles match. See, once you get your 3, you say that the triangles match, which is what you're trying to prove. Triangle FGH is congruent to triangle JIH. This line, I just copy what they have here, because you could name it in a different order, but let's not, might as well use the order they want us to prove. Okay, so the big question is, which theorem is it? So, what do y'all think? Is it side, 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 angle, or angle, angle, side? This one is side, angle, side. So if you have trouble, just look at one triangle, like cover one of them up, and you have 2 sides marked, and you have the angle between them. So it's side, angle, side. So this would be side, angle, side. There's 2 sides given, these 2, and this is the angle between them. All right, I want you guys to try example 3, or the third proof, I mean. So you guys do this third one all by yourself. I'll give you a couple minutes. So remember the steps. Mark the drawing, copy the given, and then find 3 congruences. Oops. And then say the triangles match. I got it.
Yes.
When you're marking this figure, y'all, when you mark angles, put a little arc. And when you're marking segments, put little hash marks on the segments. So that'll help you with marking the drawing. Do that first. Okay, so here's what should have happened. Angle A congruent to angle C. Angle A congruent to angle C. You should have a little arc on those 2 angles. That's how to mark angles. And then segment AE congruent to segment CE. So you should have a little hash mark on those. Angles get little arcs, segments get little hash marks. That is step 1. You mark the drawing. Then we're going to copy this into our proof. You copy the given. So angle A congruent to angle C, segment AE congruent to segment CE. That is given. By the way, in the homework, you should never have a blank proof. There should be a drawing beside it with some marks. The given should be copied, if nothing else, right? We have 2 congruences. How many do we need? We need 3. So we're going to look for the third congruence. The third congruence is almost always a shared side or vertical angles. This particular drawing, they don't have a shared side. It's not 2 triangles stuck together on a side. It's like an hourglass or butterfly looking problem. Those have vertical angles. Anytime you see an X like that where these triangles are joined, you have vertical angles here and here. And I would call them angle 1 and angle 2. The book is going to probably call them angle AEB and angle CED using 3 letters. So I'm going to put a little number 1 and a little number 2 and put angle 1 is congruent to angle 2. And the reason I know those angles are congruent is because vertical angles are congruent. Or you can put the vertical angles theorem, same thing. That's our third congruence, 1, 2, 3. And then we can say the triangles match. See, once you've got 3, you say the triangles match. In this case, it's triangle ABE and triangle CDE. Which 3-letter thing is it? It's angle, side, angle. Because there's 2 angles, and then the side is marked between them. So if you look at just one triangle to figure out what the 3-letter thing is, which postulate it is, you just look at what's marked. And we have 2 angles marked, and we have the side between them marked. So this is angle, side, angle. And that is how to do every one of these proofs. Mark the drawing, copy the given, find 3 congruences. The third congruence is usually a shared side or vertical angles, and then you say the triangles match. All right, we have one more, and I think just enough time to do it. This one is one of the harder ones, only because of that vocabulary term bisect. People forget what it means. So the only thing that'll make a proof more difficult is vocabulary that you might have forgotten, that's all. But the steps are all the same, the process is the same, so only the vocabulary makes it a little more difficult. All right, so what we do is we mark the drawing. So mark angle D is congruent to angle Y. Angle D is congruent to angle Y. And this part is something that people forget sometimes how to mark. So we need to just take our time with it and think about what it means. It says ray AB. Ray AB starts at A and passes through B like this. This is ray AB. Ray AB is bisecting angle DAY. Angle DAY is this angle right here. Okay, so that ray is bisecting that angle. Anybody remember what bisect means? Cuts it in half. That's what bisect means, cuts it in half. So that ray, AB, is cutting in half this angle, angle DAY. And if it cuts it in half, it means that the top angle is the same as the bottom angle, like that. That's what it means to be cut in half, that it goes right through the middle of them, creating 2 equal angles. See, here's kind of one of the nuances about this. Everything is trying to get you to a congruence. So this bisector is trying to get you to a congruence, and it does, it gets us there. And that's what we were given. So now, we copy that down. Angle D congruent to angle Y, that was given. Ray AB bisects angle DAY, that was given. I have 1 congruence in the given, but I have 2 marked. So remember, whatever's marked here needs to be written here. Whatever I mark in the drawing, I write in the proof. So because of that bisector, I marked this top angle, I'm going to call it angle 1, congruent to this bottom angle, I'm going to call it angle 2. You're not allowed to call those angle A because they're 2 different angles. Angle 1 is congruent to angle 2 because of that bisector. It's the definition of bisect. See, math word in the given, definition next. That's my second congruence. So now I'm at that place where we always find ourselves, where we're looking for the third congruence. Is it a shared side or is it vertical angles? Do these 2 triangles share a side? Yeah, they're stuck together at this side right here, side BA. So whenever they share a side, you write segment BA in the top triangle is congruent to segment BA in the bottom triangle. That is reflexive property. That's what you put when there's a shared side. And that's our third congruence, and now we can say the triangles match. Triangle BDA congruent to triangle BYA. And the last thing to decide is which 3-letter thing that is. And what we have is, if you look at just the top triangle, look at just that top one, we have 2 angles, and we have a side. That side is not between the 2 angles. So that's angle, angle, side, because the side is not between them. Tonight's homework is the same pages as Friday, 230 and 238, but they're just the proof ones, okay? So there's any problems.